All right, let's check and see how you did on this. So we're going to be looking at these two spinners on the left, and we're going to try and figure out how many outcomes there are, and then what's the probability of getting different combinations of numbers. So the first spinner has three different outcomes. You could get a 1, 2, or a 3, and they all appear to be the same probability. They all take up the same amount of space. On the next spinner, there's also three different outcomes. Okay, a 1, a 2, or a 3. Now a 3 is clearly more likely, but there is no 4, there's no 5. How many outcomes are there? There's 3. You could get a 1, you could get a 2, you could get a 3. So where it says each spinner is spun once, what are the total number of outcomes? Let's make a tree diagram real quick and see if it makes sense. So on your first spinner, you could have got a 1, you could have got a 2, you could have got a 3. So those are your three outcomes for the first spinner. After you spun that, let's say you got a 1. The total outcomes you could get here is a 1, a 2, or a 3. So again, the 3 is more likely. But the actual outcomes you could get is a 1, or a 3. So you could get a 1 on the first spinner, and then your different outcomes on the second spinner are just a 1, 2, or 3. You could get a 2 on your first spinner, and then you could get a 1 on the second one, or you could get a 2 on the second one, or you could get a 3 on the second one. Or maybe you got the 3 first, and then you could have got a 1, a 2, or a 3. So how many branches or how many different combinations do we have? So you have 3 here, 1, 1, 1, 2, 1, 3. You have 3 here, 2 to 1, 2 to 2, 2 to 3, and 3 here, 3, 1, 3, 2, 3, 3. That's a total of 9 outcomes. Now, is there a faster way to do that? Yes. You can say how many outcomes are on the first one? 3. How many outcomes are on the second one? 3. Multiply them together. 9 outcomes. Okay. So when we talk about our total number of outcomes, that's 9. Now, what's the probability of spinning a 3 on your first spinner? What's the probability of spinning a 3 on your first spinner? And I think we can see that's clearly 1 out of 3. 3 total outcomes. Chance of spinning a 3. Only one of these is a 3. So now, what's the probability of spinning a 3 on your second spinner? Now, here's where we need to start being careful. So there's 3 outcomes here. A 1, a 2, or a 3. But they don't all have the same chance of happening. So what we need to do in order to come up with a probability right now is somehow demonstrate these having equal probabilities, equal sizes. And so what you want to do is you want to kind of split this in half, and both of those would count as 3s. So how many total outcomes do I have now? Well, I really have 4 outcomes total. Okay. And how many of them are 3s? 2 of them. Okay, so there's really 4 outcomes here if we're going to make them all equally spaced. And 2 of them are that 3. Now that reduces to a 1/2. And some of you might have just jumped to that right off the bat. So you looked at this and you said, okay, chances of a 3 is 1 out of 3. And then you looked here and you said, well, what's the chance of a 3? Half of this is a 3. So the probability is half. It's a 1 out of 2. I could get something over here, which isn't a 3, or I could get something over here, which is a 3, and that's half, so 1 out of 2. So the chance of getting a 3 on this spinner is 1 out of 3, and the chance of getting a 3 on this spinner is 1 out of 2. So now, what's the probability of spinning a 3 on both spinners? So what we need to do is take the probability of the first one. So the chance of getting a 3 on the first one is 1 out of 3. And you're going to multiply it times the probability of the second one. The chance of getting a 3 on this spinner is 1 out of 2. So what's the probability that you spin the first one and then the second one and you get a 3 on both? You need to multiply. And it's 1 out of 6. And you could turn that to a percent. So what's the percent chance? I didn't ask for it, but what's the percent chance of getting a 3 and then a 3? You do 1 divided by 6, times it by 100, and we're going to round that up, it's approximately a 17% chance. Now let's think about that for a second. We know that this is a 50% chance, and a 1 out of 3, if we try that in our calculator, is about a 33% chance. So you have a 33% chance of getting a 3 on your first one. You have a 50% chance of getting a 3 on your second spinner. So those are pretty high percentages. They're not more than half. They're not likely, but they're not super unlikely either. But the chance of getting them back to back, so you get 33% and then you get 50%, it goes all the way down to just 17%. You have just a 17% chance of them happening back to back. So individually, they have a decent chance of happening. Get a 3 here, get a 3 here. But the chance of them happening back to back in 2 spins in a row is only 17%. So the more times you spin these and you want to get a 3 every single time, your probability and your percentages will continue to drop.